Hi, welcome to Chapter 1, Lesson 1 of our Basic Calculus class. So this lesson is called Basic Differentiation Rules. So for today, our goal is to apply the basic differentiation rules in computing or looking for the derivative of algebraic functions. So in our day-to-day life, we are often interested in the extent to which a change in one quantity affects a change in another related quantity. This is called a rate of change. For example, if you own a motor car, you might be interested in how much a change in the amount of fuel used affects how far you have traveled. So this rate of change is called fuel consumption. If your car has high fuel consumption, then a large change in the amount of fuel in your tank is accompanied by a small change in the distance you have traveled. Sprinters are interested in how a change in time is related to a change in their position. So this rate of change is called velocity. Other rates of change may not have special names like fuel consumption or velocity, but are nonetheless important. So for example, an agronomist might be interested in the extent to which a change in the amount of fertilizer used in a particular crop affects the yield of the crop. So economists want to know how a change in the price of a product affects the demand for that product. So differential calculus or differentiation is all about describing in a precise fashion the ways in which related quantities change. So the slope of the tangent at point x f of x or xy on the graph of f is called the derivative of f at x and is written as f prime of x. So look at the graph of the function y equals f of x in the figure. So three different tangent lines to the graph of f of x is drawn at three different points on the graph. So you can see here three different tangent lines. So the derivative of the function can be solved using the formula m equals the limit of f of x plus delta x, or delta x stands for change in x, minus f of x all over delta x as delta x approaches 0. Now take note, m in your algebra stands for the slope. So take note, m also here is the slope of the given tangent line. So the formula is kind of intimidating, but good news, mathematicians have arrived at a simpler method to use for the derivation of a function. So instead of using this formula, so we're going to use the various differentiation rules. So here are some of the basic rules when taking the derivative of functions. So take note that the derivative of y equals f of x can be written in any of the following ways. So you could have y prime, f prime of x, dy over dx, d over dx of f of x, or derivative of f of x in terms of x. So you could all use this symbol and it all means the derivative. So in our case, we will be using the first three symbols for the derivative. So you will encounter this often in our lesson. So here are some of the basic differentiation rules that we will discuss today. So we have the constant rule, the identity rule, the power rule, the constant multiple rule, the sum and difference rule, the product rule, and the quotient rule. So we will discuss each one of them as we go along our lesson today. So first, let us have the constant rule. According to the constant rule, if f of x equals c, where c is any real constant, then f prime of x is equal to 0. This simply means that if you're given a constant function, so the derivative of that function is always 0. So here we have some examples. we're going to find the derivative of the following functions. Number 1, f of x equals 18. Take note, 18 here is a constant. Therefore, constant rule applies. F prime of x will always be 0. Second example, we have f of x equals pi. Take note, pi is also a constant, or that is equal to approximately 3.14. So, f prime of x, since pi is a constant, will still be equal to 0. Third example, f of x equals negative 2. Take note, negative 2 is still a constant. Therefore, f prime of x, or the derivative of our function f of x, is still 0. Again, the constant rule tells us that if we're given a constant function, the derivative is always 0. Let's move to the next differentiation rule, which is the identity rule. So according to the identity rule, if f of x is equal to x, then f prime of x is equal to 1. So this simply tells us that if we have the identity function f of x equals x or y equals x, the derivative of that function is always 1. Take note, the derivative of x alone is 1. Next, we will use this as we go along. The next rule is called the power rule and is the most oftenly used. So, the power rule states that if f of x equals x raised to n for any number n, and n here is our exponent, then f prime of x, or the derivative of our f of x, is equal to n x raised to n minus 1. So basically, if we have the function x raised to n, where n is our exponent, what we're going to do is we take n, we make it as our numerical coefficient, then we subtract 1 from our exponent. So to make this clearer, let us have some examples. So we're going to find the derivative of number 1, f of x equals x cubed. Again, the derivative is n x raised to n minus 1. Again, we take the exponent, make it as our numerical coefficient, and subtract 1 from our exponent. So, going back, f of x equals x cubed will have the derivative of, take 3, make it as our numerical coefficient. Then we have x cubed minus 1. Again, take 3, make it the numerical coefficient, and subtract 1 from our exponent. So, that will be f prime of x is equal to 3x raised to 3 minus 1. So, simplify, that will be f prime of x equals 3x raised to 2, or 3x squared. So, the derivative of x cubed is 3x squared. Second example, we have x raised to 7. Again, using the power rule, we make 7, which is our exponent, as our numerical coefficient. Then, subtract 1 from our exponent. So that's 7, x raised to 7 minus 1. So, that will be x, or f prime of x, is equal to 7, x raised to 6. So, our derivative is 7x raised to 6. Third example, we have f of x equals x raised to 11. Again, using the power rule, we take 11 and make it as our numerical coefficient. Then subtract 1 from our exponent. So our derivative will be 11x raised to 10. Next differentiation rule is called the constant multiple rule. According to the constant multiple rule, so take note, C here is any constant. And if we have g of x equals c times f of x, then g prime of x will be c times f prime of x. It simply means that if our given function is multiplied by any constant, we simply get the derivative of the function times the constant. Example, we have f of x equals 3x. So our function here is x multiplied by 3. So using the constant multiple rule, okay, so we take out 3 as our multiplier or constant, and we take the derivative of x. Take note, according to the identity rule, the derivative of x is 1. So that's why we have 3 times derivative of x, which is 1. That's 3 times 1. So derivative of 3x, therefore, is 3. Second example, we have f of x equals negative 3 x raised to 7. Again, we take out our multiplier negative 3 and get the derivative of x raised to 7. So x raised to 7, to get the derivative of that, we will use the power rule. Again, take 7, make it as our numerical coefficient, then subtract 1 from our exponent. So that will be negative 3 times 7x raised to 7 minus 1. Simplify what is inside the parenthesis first. So that will be 7x raised to 7 is 7x raised to 6. So we multiply negative 3 and 7. That will give us negative 21. Then we have x raised to 7 minus 1. That's x raised to 6. So the derivative of negative 3 x raised to 7 is negative 21 x raised to 6. So third example, we have f of x equals 1/2 x raised to 4. So again, using the constant multiple rule, we take out 1/2 and get the derivative of x raised to 4. So derivative of x raised to 4 using the power rule is we take out 4, make it as our numerical coefficient, then x raised to 4, subtract 1 from our exponent. So 1/2 times 4, okay, will give you 2. X raised to 4 minus 1 will be x raised to 3. Therefore, the derivative of 1/2 x raised to 4 is 2x cubed. The next differentiation rule is the sum and difference rule. According to the sum and difference rule, if we have u of x plus v of x as functions, so if we have u of x plus v of x, then the derivative of the functions are u prime of x plus or minus v prime of x. So we take the derivative of each one of these separately and add or subtract them depending on the operation given. So we have examples. Find the derivative of the following functions. Number 1, f of x equals 2x plus 1. So, to get the derivative, we take the derivative of 2x and 1 separately. So, the derivative of 2x using the constant multiple rule is 2 times the derivative of x, which is 1, plus, take the derivative of 1 using the constant rule, that is 0. So, 2 times 1 is 2 plus 0. So, that will give you the derivative, which is 2. So, we have here f of x equals 3x raised to 4 minus 2x cubed as our second example. Again, we get the derivative of each of the terms. So, derivative of 3x raised to 4, we have to use the constant multiple rule. So, that is 3 times the derivative of x raised to 4. So, take out 4, make it as our numerical coefficient, then subtract 1 from our exponent. So, that's 4 minus 1. Minus, again, we get the derivative of 2x cubed. So, using the constant multiple rule for 2x cubed, we have take out 2, then get the derivative of x cubed, that is, take 3, then subtract 3 from, or subtract 1 from our exponents. That is 3 minus 1. Okay, so simplify. 3 times 4, that will give you 12. X raised to 4 minus 1 is x raised to 3. So that will give you 12x cubed. Minus 2 times 3, that is 6. X raised to 3 minus 1, that is 2. So the derivative of 3x raised to 4 minus 2x cubed is 12x cubed minus 6x squared. So number 3, we have the function f of x equals 4x raised to 5 minus 6x squared plus 1. Again, we take the derivative of each of our terms. So, derivative of 4x raised to 5, we take out 4. Then we get the derivative of x raised to 5. So that is 5. X raised to 5 minus 1 minus, get the derivative of 6x squared, that's 6 times derivative of x squared, that's 2x raised to 2 minus 1, plus the derivative of 1, that's a constant, so that's 0. So we simplify each. 4 times 5, that's 20. X raised to 5 minus 1, that's x raised to 4, minus 6 times 2, that's 12. X raised to 2 minus 1, that is x raised to 1. So since exponent is 1, we don't write that anymore. Plus 0, so we don't indicate the plus 0 anymore. Therefore, the derivative of our function is 20x raised to 4 minus 12x. Second to the last differentiation rule is called the product rule. According to the product rule, so if we have functions u of x and v of x, and we have it as f of x equals u of x times v of x, or it's called product because we're multiplying two functions, then to get the differentiation rule, we have f prime of x will be u of x times v prime of x plus u prime of x times v of x. Again, that's u of x times v prime of x plus u prime of x times v of x. Let's have some examples. If we have f of x equals x times x squared minus 3. So, we represent our u here as x and v is x squared minus 3. So the derivative is u of x. So we simply copy x. Then v prime of x means we multiply it to the derivative of v. So derivative of x squared is 2x raised to 2 minus 1 minus derivative of 3, that's minus 0. So no need to write that anymore. Plus u prime of x, so that means we get the derivative of x. Derivative of x is 1. Then v, we simply copy x squared minus 3. So you can interchange your factors or your addends. So we simplify x times 2x raised to 2 minus 1. So 2x raised to 2 minus 1 will simply be 2x. Then x squared minus 3 times 1 will still be x squared minus 3. So simplify. X times 2x is 2x squared plus copy x squared minus 3. Then simplify. 2x squared plus x squared will give you 3x squared, then minus 3. So, the derivative of our given function is 3x squared minus 3. Second example, we have f of x equals 3x plus 5 times 8x minus 9. So, let us take q as 3x plus 5 and v as 8x minus 9. So again, we follow the differentiation rule, u of x times v prime of x plus u prime of x times v of x. So, first, u of x, so we simply copy u, that's 3x plus 5. Then v prime means that we get the derivative of v, which is 8x minus 9. So, derivative of this 8x is 8 times derivative of x, which is 1, minus derivative of 9 is 0, plus u prime of x, okay? So that is, we get the derivative of 3x plus 5. So that's 3 times 1 plus 0. And v here is, simply copy 8x minus 9. So simplify, that is 3x plus 5 times 8 times 1 is 8 minus 0, that's still 8, plus 8x minus 9. 3 times 1 is 3 plus 0, that's still 3. Then we use the distributive property. 8 times 3x is 24x. 8 times 5 is 40, plus 8x times 3 is 24x. 3 times negative 9 is negative 27. Okay, so we have 24x plus 40 plus 24x minus 27. So we combine terms. So 24x plus 24x will give you 48x. 40 minus 27 is 13. So derivative of the given function is 48x plus 13. Another example for the product rule. We have f of x equals 2x times 3x squared plus 2. So let's say 2x is u and v is 3x squared plus 2. So again, use the product rule. That's u. So simply copy 2x times v prime. So get the derivative of v, which is 3 times derivative of x squared. That's 2x raised to 2 minus 1 plus derivative of 2, that's 0. Then v, copy 3x squared plus 2 and get u prime or derivative of 2x. So derivative of 2x is 2 times 1. Simplify. So that's 2x times 3 times 2x raised to 2 minus 1, that's also 2x. Then plus 0, that's still 2x. Plus, just copy 3x squared plus 2. 2 times 1 is 2. Okay, then multiply. 3 times 2x is 6x. So you have 2x times 6x plus, distribute 2 to each of the terms. You have 2 times 3x squared. That will give you 6x squared. And 2 times 2, that will give you 4. So simplify further. 2x times 6x will give you 12x squared. Then copy plus 6x squared plus 4. So we can still simplify this by adding 12x squared and 6x squared. So that's 18x squared plus 4. So the derivative of the given function is 18x squared plus 4. The last rule is called the quotient rule. So according to the quotient rule, again, we have u of x and v of x as functions. So if the function is u of x over v of x, where u of x, of course, is your numerator and v of x is the denominator, given that v of x is not equal to 0, then the derivative is v of x times u prime of x minus u of x times v prime of x over v squared. So examples, we have f of x equals 1 over x. So take note again, our numerator will represent u and the denominator will represent v. So in this situation, our u is 1 and v is x. So using the quotient rule, so that's v times u prime. So we copy x. Then we get the derivative of u or derivative of 1, that's 0. Minus u of x, so that's 1 times v prime, or the derivative of derivative of x here is 1, all over v squared. So v is x, so square that, that's x squared. Simplify this. X times 0 is 0, minus 1 times 1 is 1. 0 minus 1 is negative 1, all over x squared. Or that is negative 1 over x squared. So, the derivative of f of x equals 1 over x is negative 1 over x squared. Second example, we have f of x equals 2x plus 1 over x. Derivative here, so we represent our u as 2x plus 1, and our v here is represented by x. So again, use the quotient rule. V times u prime of x minus u times v prime of x all over v squared. So, v, simply copy x, then u prime, get the derivative of u. So that's 2 times derivative of derivative of x is 1 plus 1. So derivative of that is 0 minus u. So we simply copy 2x plus 1. And we have v prime. So we get the derivative of x, which is 1 all over v squared. So our v here is x. So square that, that is x squared. Now simplify. This will be 2 times 1, that's 2, plus 0, that's still 2. 2 times x will give you 2x, minus 2x plus 1 times 1 is still 2x plus 1. So, distribute the negative sign or negative 1 to each of the terms. Negative 1 times 2x, that's negative or minus 2x. Negative 1 times 1, that's negative 1. So, we put here minus 1. So, all over, we have here x squared. So, we simplify. 2x minus 2x is 0. Minus 1, that's negative 1, all over x squared. Or that is still negative 1 over x squared. And lastly, we have f of x equals x squared over 2x minus 1. So x squared is u, and 2x minus 1 represents v. So again, we follow the formula for the quotient rule. So we have v, so that's copy 2x minus 1 times u prime. Or we get the derivative of u, which is x squared. So derivative of x squared is 2x raised to 2 minus 1, or that's 2x, minus v, or sorry, that's u. So we simply copy x squared and v prime. So we get the derivative of 2x minus 1. So that's 2 times 1 minus derivative of 1 is 0. Then we square the denominator. That's 2x minus 1 squared. Okay, simplify. So here we multiply 2x and 2x minus 1. So 2x times 2x, that's 4x squared. 2x times negative 1, that's negative 2x, so we put here minus 2x. So this is simply x squared times 2, so that's negative, or we have here minus 2x squared. So square the denominator, so that's 2x minus 1 quantity squared. So simplify, we can subtract 4x squared, and we have here minus 2x squared. So 4x squared minus 2x squared, that is 2x squared. And we have here minus 2x, all over 2x minus 1 squared. So derivative of the given function is 2x squared minus 2x all over 2x minus 1 squared. Okay, so study this lesson, and I'll see you in the next one. Bye!